Hello, today we're going to go over giant stars. So this is the giant star lecture. And I've got an image here and it shows all different types of stars and both size and color. And what we'll find is that our sun, which is a normal size star, our sun is the norm, but there's exceptions to those sizes. So most stars are the size of our sun or smaller. So now we're talking about the majority of stars, like 75% of stars are the size of our sun or smaller. However, exceptions to this smaller size still exist in the universe. And then we look down here and we got size comparison where it shows our sun. And then some of the smaller, what we'll call red giants. And you can see that this is still bigger than our sun by several times. And then they can get much larger. So these red giants can dwarf the size of our sun. A star like our sun will eventually expand into a red giant. So stars like this, like our sun, over time are going to slowly get bigger and bigger. We'll talk about why. Red giant sizes vary, but usually are the size of the inner rocky planets. So if you can imagine our sun being here and this red giant extending out past what would be the orbit of Mercury or even to Venus. So they get bigger and bigger. Now, why does this happen? Well, as a star like our sun reaches the end of its life, the core starts to change its fuel source. And eventually the core starts to collapse. As it collapses, there is pressure and energy that's pushing these outer layers of the star outwards. So even while the inside is collapsing, the outside is expanding. Red giants form from older main sequence stars. The core starts to collapse and the outer layers are pushed away. So you've got this weird case again where it's shrinking in the middle, expanding on the outward edges. So we can also get these blue giants. Those are going to be a little different because of the color. The color means that there's a difference in temperature. Blue giants are also possible. The blue giant stars burn hot and have short lifespans. So these burn themselves out because they're much hotter. They burn through their fuel much quicker, and they might only last millions of years rather than billions like our star. All right. So those are the red giants and blue giants. Now let's go a step further. Next are the supergiants. Supergiants are the next larger category of stars. So you can see in this image here, here's the sun, just a little speck. And this is a blue supergiant, another one that would burn itself out within millions of years, but still huge in size. Their size dwarfs our sun and would reach towards the orbit of Jupiter. That's hard to imagine. A star that would expand past the orbit of Jupiter. Jupiter is very far away from our sun. So a star that big that would take up most of our solar system is pretty hard to imagine. But we can go one step further. The final category are the hypergiants. These are the largest stars, and their size would expand past the orbits of some of the gas giant planets. So again, we got a comparison here where you've got the sun, this little speck, and it's zoomed in from this area. So you couldn't even see the sun in this image of this hypergiant. Our hypergiants are going to usually be in the red category, red-orange category. These hypergiants would pretty much expand to the limits of our regular solar system. This is huge. This means light just to travel from one end of the star to the other would take many hours going at the speed of light. That's how big this thing is. It would take hours for light to traverse it going across. Okay, I hope this helps. Thank you very much.